All of you very good morning. Myself, Ravan Kumar, Assistant Professor in Mathematics, H&S Department. I have 18 years experience. Today we are discussing the topic related to numerical analysis. Numerical analysis. Numerical analysis and numerical techniques. In that first one, we have discussed the error analysis part. Before going to the topic of numerical analysis, in the first case, we are discussing error analysis. Error analysis. Okay, first of all, there are two types of numbers. The number in that numerical analysis, in the error part, the numbers can be divided into two types. The numbers can be divided into two types. Generally, the numbers can be divided into sets, and we already discussed in the lower classes: natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers and complex numbers. Those are the sets. Here in the numerical techniques, the numbers are divided into two types. The numbers are divided into two types. The first one is exact numbers. First one is exact numbers, and the second one is approximate numbers. The first one is exact numbers, and the second one is approximate numbers. Now, what is the difference in between exact numbers and approximate numbers? First of all, we discuss about the exact numbers. Exact numbers are the numbers which are having the exact degree of accuracy. Exact numbers are the numbers which are having the exact degree of accuracy. Exact degree of accuracy. That those numbers are called as exact numbers. Those numbers are called as exact numbers. For example, we can take as 1 by 2, 3 by 2, 1, 2, 3, so on. 1, 2, 3, so on. These all numbers are exact degree of accuracy. Accuracy means always the number, the value of the 1 cannot be changed in any way. The value of 1 by 2, that is 0.5. That value cannot be changed in the conditions of regarding whatever the applications. The number 2 cannot be changed anywhere. Those compulsory which are having the exact value, they are having only exact value, exact degree. That's the reason these numbers are called as exact number, which are doesn't having any changes in any cases. Any changes in any cases. We have compulsory the value of 2 is always 2 only. We can't change anywhere. Can't change anywhere. Those numbers are called as exact numbers. Those numbers are called as exact numbers. Next one is approximate numbers. Exact numbers are all so many numbers. You know very well, natural number system, whole number system, integer, all numbers, most of the numbers are exist in exact numbers. Most of the numbers exist in exact numbers. But what is the difference between approximate numbers? Approximate numbers. Approximate numbers are the numbers which are having certain degree of accuracy. Which are having certain degree of accuracy. That means, we are taking the example pi. The value of pi. The value of pi is generally can taken as 3.14. The value of pi is taken as 3.14, which is fixed for only 2 decimals. Which is fixed for only 2 decimals. Suppose we are taking the value of pi, that is 3.146, which is for 3 decimals. Which is for 3 decimals. The value of pi is 3.14, which is for 2 decimals, and that is fixed for 2 decimals. And 3.146, which is fixed for 3 decimals. But actually, the value of pi, the approximate exact value of pi, is 3.14159265. 14159265. Here, the value of pi changes depending on the condition. In the particular problem, they can mention the value of pi taken up to 2 decimals. That means we are taken as 3.14. Suppose the value of pi taken up to 3 decimals, we can take as 3.14. but actual the value is 3.1415926, which this is the most exact value of pi. Here the value of pi changes from one case to another case, 2 decimal for this value, 3 decimal for this value, and depending on the condition the value of pi changes. That's the reason these are example for the approximate numbers. These are the example for the approximate numbers. The value can be changed depending on the condition. Those numbers are called as a approximate numbers. Approximate numbers are those numbers which are having certain degree of accuracy. Which are having a certain degree of accuracy. The value can be changed depending on the condition. But as compared to the exact degree, that is, the value cannot be changed anywhere. Always we taken as the value of 2 is only the 2 only. The value of 3 is only the 3. But the value of pi changes. These type of values belongs to the approximate number, which is the difference in between exact numbers and approximate numbers. Exact numbers and approximate numbers. After that, significant digits. Significant digits, or are significant figures. Significant digits or are significant figures. But what is the definition of significant digits or significant figures? Significant digits, the digits which are used to express a number. The digits which are used to express a number are called as a significant digits. The digits which are used to express a number, that is called as a significant digits or significant figures. Suppose we are taken as 3.1416 and 0.0007 and 4.0067. Here 3.1416. The digits which are used to express a number. That is, what are the digits? 0 to 9 only. 0, 1, 2, 3, 4, 5, 6, 7, 8. Only these digits can be used to express any number. To express any number. That is 3.1416, 0.667, 4.0067. This is an example for the significant digits. Here, 3 is a significant digit, 1 is a significant digit, 4, 1, 6. And similar in the case of remaining numbers also, all are related to significant digits or significant figures. But here, the value 3.1416 consisting of how many significant digits? Consisting of how many significant digits? That is, it consisting of each contains 5 significant digits. Which contains 5 here. 3.1416. Here 1, 2, 3, 4, 5, which consisting of 5 significant digits. Here 0.0007, sorry, 667, which consisting of 6, 1, 2, 3. Here it consisting of how many significant digits? 4 significant digits. 1, 2, 3, 4, 5, which consisting of how many significant digits? 5 significant digits. But here we can't take 0. 0 cannot be treated as a significant digit, which can only serve to fix the decimal position. Only to serve fix the decimal position. Here 3.1416, 4.006 and 00 is also treated as a significant digits. So these two numbers which consisting of 5 significant digits. These two numbers which consisting of 5 significant digits. Here 0.667, which consisting of only 4 significant digits. Here 0 point, only after the point can be taken as a significant digits. Here 0 only can serve to fix the decimal position. Only can serve to fix the decimal position. Suppose we are taken as 0.00023. We are taken as another significant figure. 0.00023. Here, which consisting of how many significant digits? Only consisting of 2 significant digits. only 2 comma 3 represents the significant figures or significant digits. But here zeros, 3 zeros, here 1 0, we cannot take it as a significant digits, which only serve to fix the decimal position. But here 4 point, after that these 2 zeros considered as a significant digits. But before that, you can't take it as a significant digits. This is a major difference in the significant figures and significant digits. What is the definition? Significant digits and significant figures. The digits which are used to express a number. The digits which are used to express a number. That is called as a significant digits or significant figures. These are the examples for the significant digits and significant figures. Next one. Rounding off. The next definition is rounding off. What is the definition of rounding off? We frequently come across with a large number of digits. Then it is necessary to cut them. Convert into our usable number of digits. This process is called as a rounding off. We frequently come across with a large number of digits, but it only can taken as usable number of. It is necessary to cut them the digits. After that, we are taken as only usable number of digits. This process is called as a rounding off. Suppose we are taken as example. Suppose we are multiplying these two digits, 9.32689678, 8.34670921, which consisting of how many significant digits? 1, 2, 3, 4, 5, 6, 7, 8, 9. Here, which consisting of how many figures? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10 digits, which is 9 digits. You can multiply these two numbers, we get big number, which consisting of more than 10 digits or 11 digits, whatever. Every time you have to write these digits, which is very hard to write every time these 2 or 9 digits, 10 digits, 10. That's why reasons it is necessary to cut them. Usable number of digits. That's the reason in the particular problems they mentioned up to 2 decimals, up to 3 decimals, up to 4 decimals, up to 4 significant figures, up to 3 significant figures. It is necessary to cut them. After that, we are taken as a usable number of digits. That process is called as a rounding off process. Every time you can't write in this big number so many times. That's the reason we cut them to write a usable number of digits, which process is called as a rounding off process. This is very most important, rounding off. Cut them and write our usable digits. That is process, which process is called as rounding off. But in the rounding off, you have to follow some rules. I have to explain some rules here. That is, you have to round off a particular number, that is, you have to follow 3 rules. First point, the first rule is the 3 rules are based on 5. The number 5, half unit. Half unit is nothing but 5 number. They based on 5. They differentiate the 3 rules. The first point, less than a half a unit. Half means 5, number 5. Less than half a unit in the nth place. Leave the nth digit and unchanged. Less than half a unit. The value of 5, the value of the particular value less than 5. That is 0, 1, 2, 3, 4. Then just leave the nth digit and unchanged. Leave the nth digit and unchanged. That is the first condition. Less than a half a unit in the nth place. Half a unit in the nth place. Just leave the nth digit and unchanged. Leave the nth digit and unchanged. That is the first condition. Second condition. Greater than a half a unit in the nth place. Greater than a half a unit in the nth place. Half a unit in the nth place means that is more than. That is here the values are 5, 4, 3, 2, 1, 0. Here the values are 6, 7, 8, 9. The value of half a unit in the nth place, that is the greater than half a unit in the nth place, then increase the nth digit by unit. Increase the nth digit, whatever the nth digit in the particular significant digit of a particular number, just increase that digit by unity. Unity means 1. You can add that 1. That is the second part. Greater than half a unit in the nth place. Greater than half a unit in the nth place. Increase the nth digit by unity. Increase the nth digit by unity. That is the second point. Third point. Exactly. That is less than 5 is the first case. More than 5 is the second case. But exactly 5. Exactly half a unity in the nth place. If it is odd, you can increase the unity. If it is even, is unchanged. That is exactly half a unit in the nth place. Just increase the unity if it is odd. Increase the unity if it is odd. Otherwise unchanged. If it is even, you can't change that particular number. These are the 3 rules you have to follow to rounding off process. The first point is less than half a unit in the nth place. Half means 5, number 5. Half a unit in the nth place. Then increase, that is leave the nth digit and unchanged. Leave the nth digit and unchanged. The second point, greater than half a unit in the nth place. Greater than half a unit in the nth place. Just increase the nth digit by unit. Increase the nth digit by unit. Third point, exactly half a unit in the nth place. Exactly half a unit in the nth place. Increase the nth digit by unity if it is odd. Increase the nth digit by unity if it is odd. Otherwise unchanged. Otherwise means if it is even, you can not change the particular nth digit. These are the 3 rules. Okay, just small example only. I'm not explaining brief explanation. Just small examples. What are the conditions? How we are taking the particular condition. Suppose 1.658. So next second number. Suppose 30.0567 and 0.85937. Suppose some 3 numbers is given. Correct to 4 significant figures. Correct to 4 significant figures. Just remember what are the conditions to round up the particular number up to 4 significant figures. Suppose what is the nth place here? 3. 4 significant means 1, 2, 3, 4. First condition, less than a half a unit. Second condition, greater than a half a unit. Third condition, exactly half a unit. Half means 5. In the nth place, what is the number? 3. 3 means less than 5. 3 means less than 5. It is less than a half a unit. That is related to first condition. Less than a half a unit. That is related to first condition. Then what is the first condition? Less than a half a unit. Then leave the nth digit and unchanged. Just leave the nth digit and unchanged. That means 1.658. The required rounding off number up to 4 significant figures. 1, 2, 3, 4. That is 1.658. That is the first one. Leave the nth digit and unchanged. Just leave it and write the number as usual. That is the first one. Next, second, 30.0567. What is the nth place? 7. 7 means more than 5. That is greater than half a unit. Greater than a half a unit in the nth place. Nth place. What is the condition? Increase the nth digit by unity. Increase the nth digit by unity. Figures means up to 4 significant figures. 1, 2, 3, 4. Increase the nth digit by unity. What is the nth at last place? 5. You can add increase 1 to the nth place. That means 30.05. Can add unity. Unity 5 plus 1. That becomes 6. That is required answer is 30.06. The required answer is 30.06. In the nth place is 7. That is greater than a half a unit. Then increase the nth digit by unity. Nth digit means 4 significant figures. 1, 2, 3, 4. 4 significant figures. What is the fourth digit? Here, fourth significant figure 5. You can increase the nth digit by unity. Unity means 1. 5 plus 1. That becomes 6. 5 plus 1. That becomes 6. The required answer, rounding of a number, is 30.06. 30.06. And after that, 0.859378. What is the nth place number digit? 8. That is greater than a half a unit. Greater than a half a unit. Then increase the nth digit by unity. How 4 significant figures. Here 0 cannot taken as a significant figure, which only serve to fix the decimal position. Only to serve to fix the decimal position. And that means 1, 2, 3, 4. 4 digits. That is 0.8593. Nth place. What is the nth place number? 3. You can increase the nth place by unity. Nth digit by unity. Unity means you can add 1. 0.8594. 3 plus 1. 3 plus 1. That becomes 4. These are the rules. After that, exactly half a unit means that is based on that particular one. If it is even, you can leave it unchanged. Suppose if it is odd, increase the nth digit by unity. Suppose take some example. 2, 4, 6, 7, 8, 5. Suppose I am taking this example. 3.246785. What is the nth digit in place? 5. 5 means exactly half a unit. Exactly half a unit in the nth place. Nth place means after 4 significant figures. 1, 2, 3, 4. In the fourth place, 6. 6 is the even number. 6 is the even number. Even number means you can't change. Unchanged. Unchanged means what is the required answer? 3.246. 3.246 only. The nth place is 5. Exactly half a unit. Exactly half a unit means increase the nth digit by unity if it is odd. Increase the nth digit by unity if it is odd. Otherwise unchanged. Unchanged means even number. If it is exists is a even number. The value cannot be changed. Here 3.246 up to 4 significant figures. That is 6. 6 is a even number. You can't change. The required answer is 3.246. Suppose 1.235795. Suppose I am taking another number. 1.235795. In the nth place, what is the number? 5. 5 means that is exactly half a unit in the nth place. Next, up to 4 significant figures. 1, 2, 3, 4. 4. Fourth place, that is a 5. 5 is a odd number. 5 is a odd number. Odd number means increase nth digit by unity. Unity means what is the required answer? 1.23. 5 plus 6, that becomes 5 plus 1, that becomes 6. 5 plus 1, that becomes 6, which is a odd number. Odd number means increase the nth digit by unity. Unity means 1. 5 plus 1 means 6. These are the particular rules you have to rounding of a particular number. Rounding of a particular number. Rounding off. What is a rounding off? Frequently come across with a large number of digits. Frequently come across with a large number of digits. It is necessary to cut them. It is necessary to cut them for usable number of digits. For usable number of digits. The process is called as a rounding off process. The process is called as a rounding off process. In rounding off, you have to follow 3 rules. The first one is less than half a unit in the nth place. second one is greater than half a unit in the nth place, third one is exactly half a unit in the nth place. Half means 5. Based on 5, you can differentiate these 3 conditions. This is the rounding of process. The next one. Next, errors. Errors. There are 2 types of errors. Errors can be categorized into 2 types. The first one is inherent errors. The first one is inherent errors. The second one is truncation errors. The first one is inherent errors, second one is truncation error. The errors can be divided into 2 cases. The first one is inherent error, the second one is truncation errors. First of all, we discuss the inherent errors. Inherent. What are the inherent errors? Inherent. Most numerical calculations are inexact. What are the inherent errors? Most numerical calculations are inexact. Either the data being approximate or due to the limitation of the data. Either the data being approximate, the given data is approximate, otherwise due to the limitation of the data. Due to the limitation of the data means first your data being approximate. Approximate means suppose some particular problem, so the value of pi take up to 2 decimals, up to take 3 decimals. But the exact figure is I am giving already 3.1415926, but we are taken as only 3 decimals, 3.146, up to 2 decimals, 3.14. That's the reason. The data being approximate, here the data being approximate. Otherwise, due to the limitation of the data, due to the limitation means we are going to some calculators. Desk calculators, digital calculators, some computers. Suppose in the calculators, the calculator allow up to only 10 decimals or 9 decimals or 11 digits. So 9 digits or 10 digits or 11 digits. Suppose we are multiplying the 2 numbers. Suppose one number is 9 digits into another number is 10 digits. We get 14 digits. We get 14 or 15, 16, whatever name. But the calculator gives only 9 digits. Suppose we take as example 3, 5, 6, 7, 8, 9, 6, 8, 7, 8, 3, 4, 2, 6, 7, 8. Some number is here. We are multiplying these 2 digits. Here up this 1, 2, 4, 6, 9, 3, 4, 6, 9, 10. This is a 12 digit number. This is 9 digit number. You can multiply these 2 numbers, we get 14 or 15 digits. We are multiplying these 2 numbers, we are getting 14 or 15. But in calculator that give only 9 digits or 10 digits. But what are the remaining digits? We are multiplying, we are getting 14 digits. But the calculator give only 9 or 10 digits. What are the remaining digits? The remaining digits can be deleted. And due to the limitation, the data being, due to the limitation, the numbers being deleted. That's the reason some errors exist. We are deleting 5 to 6 digits. That is the first point. The data being approximate. Approximate means we are calculating 32 pi up to 2 decimals. Up to 2 decimals means we are taken as 3.14 only. Up to 3 decimals we can mention 3.146. But actual value, the most approximate value 3.1415926. Some number is there. But we are delete some particular digits, then errors exist. Data due to the data being approximate or the data limitation of the data. That is a calculators, digital computers, whatever it may be, the data being deleted. That's the reason. Due to this limitation, due to this approximation, the errors are exist. These errors are called as inherent errors. These errors are called as inherent errors. In inherent errors can be reduced. The inherent errors can be minimized, can be reduced by taking the data being exact. By taking more exact data and data, otherwise we are taking the data in up to more significant figures. Here we are taken as only 2 significant digits or 3 significant, but we are taken as the more than one more significant figures as compared to the previous one. Then only the data can be, the error can be minimized. You can't delete it totally. The errors can be minimized. That is the error. That error is called as an inherent error. That error is called as an inherent. In hand calculations also, we can take every time we can take one more significant figure. We can take one more significant figure to reduce the error. One more significant figure to reduce the error, but we can't delete total error. Only we have taken number of digits, taken a more number of digits, that the error can be minimized. The error can be minimized. Then those errors are called as inherent errors. Those errors are called as inherent errors. Is it clear? Once again I am explaining inherent errors. In most numerical calculations are in exact. Either the data being approximate or due to the limitation of the data. Data being approximate or due to the limitation of the data. Due to the limitation of the data. Suppose in calculators, suppose you are taken as a desk calculator, digital computers, allow some 9 digits, 10 digits, or in computers 30 digits or 40 digits. But we are multiplying so many digits, so we are getting so many big numbers consisting of 30, 40 digits. What are the remaining digits? The digits can be deleted. The digit can be deleted means the error can be exist. Otherwise, the data being approximate. Approximate means we are taking the value of by up to 2 decimals, 3 decimals. But that most exact value consisting of up to 9 decimals, 9 digits. But we are deleting some digits. Suppose the value, most approximate value is this value. But up to 2 decimals means we are taken as 3.14 only. But we are deleting these digits. We are deleting these digits means compulsory there must be exist error. That error is called as inherent errors. And due to the limitation, multiplying this limitation, we get 30 to 40 digits. Only that it can take only 10 digits or 15 digits. We can remove the remaining digits. Then error can be exist. This error is called as an inherent error. This error is called as an inherent error. This error can be minimized or reduced to taking most approximate value. Most approximate value. And in every calculation, we can take up to more number of significant figures. You can take here 2 significant figures. You can take 4 significant, 5 significant. That error can be minimized. That error can be minimized. That is the case related to the inherent errors. That is the case related to the inherent error. These type of errors are called as inherent error. Errors can be minimized. In every step of calculation, we can retain at least one more significant figures. Retain at least one more significant figure. Then only we can reduce some error part in that inherent errors. That is the first one is inherent errors. The next one, truncation errors. The next one is truncation errors. Truncation errors are exist. The truncation errors are exist in infinite series f of x. For calculating infinite series f of x. The truncation errors are errors which are existing in infinite series f of x. That is infinite series means e power x. Suppose this is e power x expansion. 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 plus sin x sum expansion, cos x sum expansion, log x sum expansion. Suppose in that particular infinite series, suppose I taken as e power x, I am taking e power x 1 plus x by 1 factorial plus x square by 2 factorial, x cube by 3 factorial and so on. In that particular one, you have to calculate value of e power x at x equals to 1.5. Giving one condition. Find the value of e power x at x equals to 1.5. Just substitute the particular value. E power x, e power 1.5. 1 plus 1.5 by 1 factorial. 1.5 whole square by 2 factorial, 1.5 whole cube by 3 factorial, so on. So on means 1.5 whole power 4 by 4 factorial, 1.5 whole power 5 by 5 factorial, and so on, 6 whole power 6 whole powers, and so on. But we are taking only up to, suppose we are simplifying. In numerical analysis, you must use the calculator only. All problems are doing with only the calculator. The most calculation part is there. Compulsory we can utilize the calculator. Here 1.5 by 1 factorial means 1.5. 1.5 whole square, that becomes 2.25 by 2 factorial. 2 factorial means 2. And so on. But we are taking up to whole power 2, whole power 3, whole power 4 only. But we are removing whole power 5 by 5 factorial. And x power 5 by 5 factorial, x power 6 by 6 factorial, up to so on. So many terms are there, but we are neglecting those terms. We are neglecting those terms. But we are taking only up to 3 whole power 3, up to whole power 4 only. But we are not taking that particular value. It means we are neglecting or we are deleting some digits. We are neglecting or we are deleting some digits. Then the errors are exist. Then errors are exist. These errors are called as a truncation errors. These errors are called as a truncation errors. The truncation errors are errors which are exist in an infinite series. For example, we are taken as e power x. In that e power x, expansion is 1 plus x by 1 factorial, x square by 2 factorial, x cube by 3 factorial, x power 4, x power 5, x power 6, so on. We are calculating, we are taking e power x at x equals to 1.5 or whatever the number is given. But we are taken one up to whole power 3, up to whole power 4, up to whole power 5 only. But we are not taking the total number of digits. That's the reason we are neglecting or we are removing the particular digits. We are neglecting or we are deleting the digits means compulsory they must be exist in error. This error is called as a truncation error. This error is called as a truncation error. These truncation errors can be minimized. We can't delete totally, but we can minimize these truncation errors. We can take more number of figures. That is up whole power 3, whole power 4, whole power 5. The power should be taken more as compared to the previous one. But we can't delete totally. But we are minimizing the truncation errors. We are taking up to more figures. That is whole power 3, whole power 4, whole power 5, whole power 6 only. But we are not doing totally. This error is called as a truncation error. This error is called as a truncation error. That is the first one is inherent errors. The second one is truncation errors. These two errors are existing in most numerical calculations. But in that errors part, inherent errors and truncation errors, they can be having absolute error, relative error, and percentage error. Absolute error, relative error, percentage error. Very important. Absolute, relative, and percentage. Absolute error. Observe the definition for the absolute error. The absolute error is denoted by the symbol EA. Is denoted by the symbol EA. Error of absolute. It is defined as the numerical difference between the exact value of the quantity and approximate value of the quantity. The numerical difference between exact value of the quantity and approximate value of the quantity. That is EA equals to x minus x1 or xn. EA, absolute error, is denoted by the symbol EA. The numerical difference between exact value and approximate value. Here x is the exact value of the quantity and xi is the approximate value of the quantity, which is the definition for absolute error. And x minus xi is also denoted with the symbol delta x. Is also denoted with the symbol delta x. Absolute error, which is defined as absolute error. And the relative error. The relative error is denoted by the symbol ER. Relative error, that is ER. Absolute of error EA. Error of absolute, error of relative. The relative error is defined as EA by x. That is absolute error by exact value of the quantity. Absolute error by exact value of the quantity. EA means also it can be written as x minus xi by x. Otherwise delta x by x. Otherwise delta x by x. Which is the definition of relative error. Relative error is denoted by ER and it is defined as EA by x. Absolute error by exact value of the quantity. That is EA by x, x minus xi by x, delta x by x, whatever. That is the relative error. The last one is the percentage error. The percentage error is denoted by EP. The percentage error is denoted by EP. And it is defined as, in the name itself, percentage. That is 100 times of relative error. 100 times of relative error. EP equals to 100 into ER, which is called as a percentage error. Absolute error, relative error, percentage error. Absolute error is denoted by EA. And relative error is denoted by ER, and percentage error is denoted by, that is exact value minus approximate value. Exact value minus approximate value. X minus xi. ER, absolute error by exact value. Absolute error by exact value. Percentage error, 100 times of the relative error. These are the error analysis part in the numerical analysis. Very, very important topics. Okay, all of you. Thank you. In the next class, we discuss the remaining topic, the general error formula. Okay, thank you, all of you.